Welcome back. Today what we're going to do is we're going to be going over inscribed angles. Alright, at the end of today's lesson you'll be able to understand what an inscribed angle is. Use inscribed angle properties in circles, have knowledge of what happens when right angles are inscribed in circles, inscribe quadrilaterals inside circles, understand the different secant rules, and determine what the properties are of tangents that are used in conjunction with circles. Alright, you got that? Seems like a lot, but really isn't too much. Now, first thing I want to do is start with the do now, 10.4a. Let's get it going. Ready to go over it? All right, so it says, if the measure of arc TV is 121, what is RS? Very simple question. Because they have the same chord lengths, that means the arcs are indeed congruent, so they're both 121. All right. Find the measures of CB, arc BE, and arc CE. So, because this is a right angle, perpendicular, and because this is a diameter, it means these chords are equal, therefore these arcs are equal. So all you do is you set the arcs equal to each other. 4x equals 80 minus x. All right, add x to both sides, 5x equals 80. Divide by 5 and you get x is 16. Seems easy enough to me. Now, but that's not what it asked. It asked you to find CB. So CB is 4 times 16. Oh, let's go BE first. 80 minus 16 is 64. CB is 4 times 16, which is, guess what, also 64. And C to E is 2 times either one of them, or add them together, and you get 128. Good? Awesome. Problem C. AB here is 27. EF and GF are both 7, meaning they're congruent. They also both form 90-degree angles. They're perpendicular with the chords, meaning the two chords are equal, meaning CD equals whatever AB is. And where are we at? AB equals CD, so it is 27. All right? Nothing to it. And it didn't matter what this number was. All that matters is this number right here. Easy do now to start class. All right, so let's go. Now we're going to go over 3-4 definitions. You may or may not know some of them. Inscribed angles. So what do you think that is? Does anyone know what the word inscribed means? Well, I'll give you a hint. There's your picture. So it is number 1, the vertex is on the circle. Okay, so it has to be on the circle. Number 2, the sides contain chords. All right, so pretty much an inscribed angle is an angle inside the circle on the circle. Now, what inscribed angles do is they form things called intercepted arcs. So what do you think the intercepted arc is? You think it's this arc, that arc, or third arc? Pick a number. 1, 2, 3. And you should have picked inscribed angle here. The lies on the intercept of the inscribed angle. So where does this inscribed angle intersecting? If you would have picked 2, you are correct. All right, the endpoints are on the angle. It pretty much right between the angle. So we go out, intercepted arc is the piece between. Inscribed polygon. All vertices are on the circle. All right? And it is inside the circle. So that's an inscribed polygon. All right? What do you think circumscribed? Kind of like the opposite. So inscribed is inside. The circumscribed circle is the circle that is around the polygon. So inscribed, inside. Circumscribed, outside. All right? So it contains the actual polygon. We're not really going to use that too much, these two. These are the biggies today. Got it? Awesome. All right. Circle, quadrilateral. And the polygon can be any shape, as long as the sides are straight, like triangle, quadrilateral, pentagon, hexagon, dodecagon, all that fun stuff. Measure of an inscribed angle is 1/2 the measure of the intercepted arc. That's the rule. That is the rule that we will be using, the most important rule here. Measure of the inscribed angle is 1/2 the measure of the arc. So the measure of ATB angle is 1/2 of the measure of AB. Conversely, the measure of this arc is what related to the measure of the angle? What's the opposite of 1/2? Boom, 2 times the measure of the angle. This is the key here. 1/2, 2. Angle, 1/2 of arc, arc twice as much as angle. Remember, the arc is equal to the central angle. These are equal, central angle arc. So that means that the inscribed angle is also half of the central angle. So let's look. Find the measures in circle P, example 1. So we're going to find the measure of angle S and RQ. So try it on your own if you can. Let's see. S is right here. So if this is 60, S is what compared to this? Well, we're going to use this arc, the inscribed arc, RT, and S is half of the measure of RT, arc RT. So it's half of 60. Half of 60 is 30. And that's all there is to this. Yes, it is that easy. So now we're going to find the measure of QS. Well, we have to find RQ. RQ is this. So now we're going to be doing a little crazy stuff here. So first thing when you're finding RQ, you have to find QS. So what is QS related to 37? Oh, we have QS right here. So it is 2 times what angle? QRS, right? What's angle QRS? 37. 2 times 37 is 74. So this angle right here, whoops, is 74, right? RS is the diameter, meaning this is a semicircle. So you got 74 subtracted from, how many degrees is a semicircle? 180, because we're finding RQ. All right? So we got 180 degrees, which is this whole half. So just look above my hand, my forearm. All right? So you got minus this equals 180 minus this piece. So 180 minus 74, which you found to be right here. And you got 106. So RQ is 106. It's just a little bit taking it up a notch on you. All right? Ready for the next one? I want you guys to do problem 2. Find the measure of angle T and measure of RQT. And do 3 too. Measure of RS and measure of angle TV. All right, let's go over them. Measure of angle T. Right there. Look for the inscribed arc. Inscribed arc is RS, so it's half of RS. Half of 48, which is 24. QT. Measure of RQT. So what angle is that related to? Take the angles, go down. So it is 2 times QRT. So 2 times, the angle right there is 50. 2 times 50 is 100. You don't necessarily have to write this step right here every time. You could just go into the numbers. But I want to make sure you guys see where I'm getting numbers from. Number 3, find the measure in circle P. All right, measure of RS. So RS is this arc. So now let's look at the angles. We have to trace it. Goes to T, goes to T. All right, so it's 2 times the measure of RTS. And this little green box right here represents 90 degrees. So 2 times 90 is indeed 180. TRV. So angle TRV, 180. TRV is this angle right here, T to R to V. So what arc do we use there? We're going to have to use arc TV. Now, we don't know what TV is, but we know that this is 76. We know that this is 180, this is 42. And we know that the entire circle is how many degrees? 360. So we could find TV by doing that. We could say 180 plus 76 plus 42 plus whatever TV is equals 360. Combine these like terms. All right. You get 298 plus whatever the TV is 360. Subtract 298 and you get 62. So angle TV here is 62. So now we can find angle TRV because it is half of 62, which is 31. All right? Look at that. You guys are doing advanced problems right here. Ready to take it up a notch? Let's go to example number 4. This is actually easier. Find the measure of arc HJ and the measure of angle HGJ. What do you notice about the 2 angles? So let's look. So first thing we're going to find HJ, which is right here. So what is that related to? It's related to angle HFJ. All right, so it's 2 times that angle. So 2 times 39 is 78. So now we want to also find the measure of HGJ, H to G to J. So this is 78. Now this angle is related to, once again, the same arc. So it's half of this arc, and half of 78 equals 39. What do you notice about the 2 arcs? what do you notice about the two angles? They are congruent. Now, why are they congruent? Does anyone know? Guess. Say an answer. Louder. They're congruent because they share the same arc. See how both endpoints of their angle are in the same place? So no matter, if I just took this tip and moved it all the way around here and kept these two endpoints the same, the answer would be 39 no matter what I did, because this is 78. Got it? Measure of RS and the measure of STR. Go. Oops, I already put my RS up there. RS is right here. 2 times 31, which is 62. Since that's 62, you want to find STR. Shares the same arc. So half of 62 is 31. Notice they are congruent. 31, 31. All right. Any questions? Awesome. Why don't you guys attempt problems 1 through 6? Would have been your homework. All right. Let's go over problems 1 through 6. Measure of angle A is half of the measure of BC, half of 84, which is indeed 42. Angle G, well, this is 120, and this is 70. We could find this because all three add up to 360, right? So 70, 120 plus, oh, this was FD. I got rid of the letters. Equals 360. That is 170. So since this is 170, angle right there, what do we do? Half of 170 is 85. All right? Awesome. Find angle N. Well, 180 minus 360, since this whole thing is 180, and this piece is 160, that means this little teeny piece right here is 20. Angle N is half of 20, which is 10. All right? You got to keep on using 360 180s, depending on if it's the whole circle or if it's the diameter. Find the measure of RS. Well, that is 2 times the measure of the angle inside. 2 times 67 is indeed 134. Get some in your way. The measure of VU. VU is this angle. Well, once again, semicircle 180. If this inside angle here is 30, TV would be 2 times 30, which is 60. So now we got this to be 60, and the whole thing right here is 180. So how do we find UV? 180 minus 60, and you get 120. Easy as pie. WX, right here. Well, if this is 75, you can find WY to be 2 times that, which is 150. So 150, 110, and whatever WX is, add up to 360, right? 260, subtract it from 360, WX is 100. Right? Can't just have you multiplying and dividing things by 2. That's way too easy. Got it? Awesome. Number two. Let's do these problems right here. Name the 2 pairs of congruent angles. All right. Well, measure of C, A to D, equals C, D, D. And also with this angle right here, I didn't label the colors. With this arc right here, B, D, A, and A, C, B. This one right here, using this arc, you have M, J, L, and M, K, L. Using the blue arc, you have J, you start with the endpoint on the arc, vertice, endpoint, J, L, K, and then you can go J, M, K. The only thing changing here, as you guys should notice, are the vertices. This one right here, W, X, Z, W, Y, Z. All right? X, W, Y, X, Z, Y. Got it? Not very difficult. All right. Another do now, 10.4b. Find the measure of GHJ. I gave you a lot of hints here. I gave you all the colors. So that is half of 100, which is 50. Find the measure of CD. 2 times 40, which is 80. All right. RS. See, find this angle. Well, this is 31. This is 62. And this is half of 62, which is 31. Share the same arc, congruent angles. H. Half of 90, 45. T, 2 times 38 is indeed 76. W, X, Z. Well, if this is 72, this is 144. Half of 144 is also 72. Or share the same arc, share the same angle. Got it? Easy as pie. All right, we got a couple more slides to do, and then we'll be done. Corollary to the Inscribed Angles Theorem. Corollary 1, if two inscribed angles of a circle intercept the same arc, then the angles are congruent. This is what we've been doing for the last bit of time. So what this means is, I've been trying to explain this to you. ADB, if that is going to be sharing arc AB, right? So that means that ACB is congruent to it. Name two pairs of congruent angles. Notice that QRP is congruent to an angle, let's see. So what two angles are congruent? We just did a bunch of examples like this, right? So, what do we got here? QRP, oh, so these two angles are congruent. So right here, QRP, and what other one? It's sharing QP, so it has to be Q, go, SP. Right? So that means that the two angles, QRP and QSP, are congruent by the theorem. And also, is there other two angles? R, so let's erase that, let's start over. RQS, RQS, what is that congruent to? Well, that shares arc RS, right? And what other angle shares that? RPS. Because the angles are congruent, the measures are congruent as well, right? Got it? Easy. Congruent angles have the same endpoints, but different vertices. Just explained that before. All right, ready? We're going to take it up a little bit. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is the diameter of a circle, then the triangle is a right triangle, and the angle opposite the divider is a right angle. Watch. Measure of ABC is 90. If and only if, what has to be the diameter? Right there, AC. Now the reason for that is, a diameter makes this how many degrees? 180, right? Half of 180 is 90. So what all these words say is, anytime you have a diameter and you inscribe the angle with the endpoints of your diameter, that angle will be 90 no matter where I put it. Okay, so no matter where I throw this angle, it is going to be 90 degrees. Is that interesting? If a quadrilateral is inscribed in a circle, if and only if its opposite angles are supplementary. So what that means here is DCEFG all lie on this circle. If and only if all three of these angles add up to, how many degrees is a quadrilateral? 360. Because the circle is 360. Got it? Now opposite angle supplementary means D and F have to add up to 180. E and G also have to add up to 180. Alright? Now, let's do some examples here. We're going to start with some inscribed quadrilateral. So, PQRS is inscribed in a circle, so opposite angles are, what did we say the word was? Because with an S, supplementary. So that means that opposite angles have to add up to, how many degrees? 180. Remember, complementary is 90, supplementary is 180. So, P and R are 100 plus Y have to equal 180. Subtract 100 from both sides, and Y is 80 degrees. Why don't you try to find angle S? All right, so Q plus S also equals 180 because they are across from each other. They're supplementary. 88 plus X equals 180. 180 minus 88 is 92 degrees. All right, why don't you guys attempt problem B? Do a little bit of algebra in here. Opposite angles are supplementary. Now you should be done with this already. J plus L equals 180. J is 8x plus 4x equals 180. 8x plus 4x, you combine like terms. 8 plus 4 is 12. The x's just stay x because they are a common variable. 12x equals 180. To solve for x, you divide by 12, and x equals 15. All good? K plus M. All right? 3y and 3y. equals 180. 3 plus 3 is 6y is 180. Divide both sides by 6 and y equals 30. All right? Very easy concept to use. Any questions with these? Email me, contact me. All right, let's look at problem number 8. In a right triangle is inscribed in a circle. The radius of the circle is 5.6 centimeters. What is the length of the hypotenuse of the right triangle? Wow, that's a lot of stuff. No, it's not. All right, so the radius of the circle is 5.6. The hypotenuse is the diameter, right? So if the radius is 5.6, what's the length of the hypotenuse? Diameter is what related to radius? Twice the radius. So 2 times 5.6 is indeed 11.2. So this would be 11.2. What would this angle be? 180. This would be my diameter, even though you don't see a circle in the middle, center points, because this is 90 degrees. All right, very simple, silly thing. Find the values of A and B. All right, so why don't you guys find those real quick? Good. You should use that opposite angles in a quadrilateral are indeed supplementary, meaning they add up to how many degrees? 180. A plus C is 180. That's a 90-degree angle, right? 5A plus 90 is 180. Subtract 90 from both sides and divide by 5, and you get A is 18. 5 times 18 is indeed 90. Good way to check your answer. B and D also add up to 180. 4B plus 96 equals 180. 4B equals 84. 84 divided by 4 is 21. We all good? Awesome, easy. All right, so let's finish up with these problems. Let's see if you got them right. Q plus S equals 180, right? Subtract 80, x equals 100. Y plus 75 equals 180. R plus P. Y equals 105. Let's get into some algebra here. Opposites. 2a and 2a equals 180. 4a, not 4a squared, 4a equals 180. 180 divided by 4 is 45. Opposite. How do you know they're opposite? They're not opposite if they're right next to each other. All right? They can't share the same side. 2b and 4b, K and M. 6b equals 180, b equals 30. All right? Opposite. A and C, or B and D. So B and D are x plus 82 is 180. X equals 98. A and C are also supplementary. Y plus 68 equals 180. Y equals 112. This one right here. What do we got? T and V across from each other. 18x equals 180. X equals 10. S and U across from each other. Okay, this arrow points to that's the angle. So what do we got? We got C and 2C minus 6. Combined like terms. C plus 2C is 3C. Minus 6 is 180. Add 6 to both sides. 3C is 186. Divide by 3 and C is 62. Good? Any questions with this? We're going to finish up with one more concept, and then we'll be good. All right, theorem 10.9. If a blank and a blank intersect at a blank on a circle, then the measure of each angle formed is a blank of the intercepted arc. Well, actually, this is a couple theorems. Kind of fibbed a little bit. So if a, what's this blue line called? We went over the definitions before. Hits the circle at one point, so it is a tangent. What is this orange line called? It hits the circle at 2 points. A tangent and a chord intersect at a point on the circle, then the measure of each angle formed is blank of the intersected arc. So what are each one of these angles formed? They are 1/2 of the intercepted arc. So, for instance, measure of angle 1. What arc is intercepted with the tangent line and the chord? Think. It's actually between this point and the end point of here. So the answer would be the arc is 2 times the angle, and the angle is 1/2 the arc. So the measure of angle 1 is 1/2 of arc AB. Remember, you can use 2 letters here because it's a minor arc. All right? Now, conversely, the measure of AB is what compared to this angle? 2 times the angle. The measure of angle 2, what arc is related to angle 2? A CB. All right? Now this angle right here is what compared to this arc? It is half of the angle, measure of the arc, angle of the arc. And conversely, the measure of the arc is twice the angle. All right, because look at these two angles add up to 180, right? This whole circle adds up to 360, so that's why it makes perfect sense. Got it? Oh, there we go. Measure of angle 1 and angle 2 is 180. Measure of the two arcs is 360. 180 is half of 360. 360 is twice 180. See, getting ahead of myself here. Let's do two examples. Line K is tangent to the circle. Find the indicated measurement. So measure of angle 1. How is it compared to that? The angle is half the arc. So measure of angle 1 is compared to arc AB. So it should be half of measure of AB. The measure of angle 1 is half of 132, which is 66. All right? In this case, find the arc. Opposite. So the measure of the arc is 2 times the angle. So the measure of EFD, E to F to D, is 2 times what? What angle? E, D, line. So it's 2 times the measure of angle D. I'll just put angle D here because there is no second point. It's obviously the larger angle D. And 2 times 110, which is 220. I should have put another letter here, but oh well. You good? Awesome. Ready to do a couple more examples? Try 15 through 19. All right, going over 15 through 19. Measure of angle 1. Angles are half of the arc. So it's half of 130, which is 65. Measure of arc, K, J, L. Arcs are twice. So 2 times 125 is indeed 250. Measure of angle 1 here, tangent, chord. Okay, related to this arc right here. So it's half of 210, which is 105. Measure of arc, X, Y. You go this way as opposed to this way because 2 letters means minor arc. 2 times 80 is indeed 160. Measure of R, S, T. Angle, arc, related, twice that is 196. If I had to find this, I would just take the 196, subtract it from 360. All right, but I didn't have to. All right, try these couple homework problems. Do these 2 first. Good. All right, what do we know about opposite angles? They are supplementary. They add up to 180. So x plus 80 equals 180. Subtract 80 from both sides, and x equals 100. Y plus angle S and Q are equal, so y plus 95 equals 180. Y equals 85. This problem right here, E and G will go first. M plus 60 is 180. Subtract 60, M is 120. F and D, all right, 60 plus 2K is 180. 2K is 120. Divide by 2 and K is 60. All right, let's just finish up. That's it. So we are done with the lesson for today. I am very glad that you guys are good, and I will see you next lesson. All right, goodbye.